Amplifiers offer gain to signals. The gain given by the amplifiers is supposed to be fixed or constant, but in practice it is not so. Gain varies. It depends upon the circuit in which the amplifier is inserted. To be precise, the gain by the amplifier, it depends upon the impedance level of the point in the circuit where the amplifier is inserted. The input and output impedances of the amplifier relative to the impedance level of the insertion point actually decides to a great extent the gain offered by the amplifier to the signal. For this reason, gain becomes variable and also it becomes unknown. This is a serious problem. It has to be tackled. It has to be addressed. Variable amount of gain, unknown amount of gain. These are so serious problems to a design engineer that one cannot go further unless these two problems are addressed. Feedback concept is helpful, useful in addressing these issues. By selecting appropriate mixing method, it is possible to adjust the input impedance level of the amplifier. Similarly, by choosing appropriate sampling method, it is possible to adjust output impedance level of the amplifier while implementing feedback. Once feedback is implemented with proper or appropriate mixing and sampling circuits, the problem of variable gain, the issue of unknown gain, they disappear. Analog circuits, feedback amplifiers, part 2, series on semiconductor devices and circuits, lecture number 9.11. Feedback is a versatile, sophisticated circuit technique. In this technique, a signal is generated from the output of the system. In the present case, the system is amplifier. The generated signal is then brought to the input side and then it is combined with the output of the input signal source. This combining can be in phase, it can be out of phase. If it is in phase combining, then it is called positive feedback. If it is out of phase combining, it is called negative feedback. There is a terminology got developed around the technique of feedback, like sensitivity, desensitivity, return difference, etc. In the present session, the focus is on definition, description, and understanding of various terms we encounter while studying feedback amplifiers. In addition, we also spend some time on the benefits we get when feedback is applied to amplifier circuits. So now let us move to begin the course session. The session starts with defining positive and negative feedback in a formal manner. What is negative feedback? Here, feedback signal is combined with the signal source in such a way that input to basic amplifier is less than that in the absence of feedback. What happens in a negative feedback is the feedback signal, which is generated by sampling the output. This feedback signal, is combined in such a way that it subtracts from the output of the input signal source. Therefore, the input to the basic amplifier becomes less. Naturally, output will be less. This is basic amplifier. Sampling the output, feedback signal is generated. In fact, sampled output is passed through a network. This network is called beta network or feedback network. The output of the beta network, feedback network, is feedback signal. Now, this signal is combined with the output of the input signal source. If combining is in such a way that both gets added, then the input to the amplifier becomes larger than the input to the amplifier in the absence of feedback. If feedback signal is subtracted from the output of the signal source, then input to the amplifier, it is going to be less. Naturally, output is also going to be less. In such a case, the feedback is called negative feedback. So negative feedback reduces input to the basic amplifier. As a result, output also comes down. Then what is positive feedback? Feedback signal is combined with the signal source in such a way that input to basic amplifier is more than that in the absence of feedback. So in positive feedback, this signal which is generated from the output feedback signal, it is combined with the output of the signal source in such a way that these two get added. A larger signal comes into being at the input terminals of the basic amplifier. Of course, as a consequence, output of the amplifier also increases. This is positive feedback. Before going further, it is to be mentioned that it is the negative feedback that is used widely. Positive feedback, some applications are there, but it is rarely used. The reason for its rarity is that it's to instability in the system. Unwanted oscillations can come into being with positive feedback, so it is avoided. Here is shown a flow diagram or block diagram of a single loop negative feedback. It is a single loop system because you can find only one loop. One can have any number of loops, 2 loops, 3 loops also can be there, but here only one loop is there. That's why it is a single loop negative. You see here at the input side of the amplifier, the feedback signal is subtracted from the output of the input signal. Subtraction is there, so therefore it is negative. Feedback means output. Output is brought to input side and is fed to the input side of the amplifier. The single loop negative feedback. We use single loop feedback for improving the performance of amplifier. We don't go for multi-loop feedback systems because they increase the complexity. In this diagram also, one can see basic parts of feedback technique applied to amplifiers. This is basic amplifier. Its gain is A. In the absence of feedback, here is signal source. It gives some output. It goes into the amplifier, gets amplified, comes out, and that output appears across the load. To improve the performance of the amplifier, feedback is applied. How it is implemented? This is output signal. It is the sampler, the part of the circuit that exists here. That is common point of a feedback signal and output circuit. Sampler gives out signal and it is passed through a feedback network. Usually it is passive network. It steps down the signal. The output of feedback network is feedback signal and then it is mixed with the output of input signal. The circuit that is used for mixing is called mixer or comparator. Mixer or comparator, as it is negative feedback, it subtracts the feedback signal from the output of input signal. The difference signal is then input to the basic amplifier. By applying this technique, feedback technique, as already mentioned, one can improve the performance of the amplifiers. What are the improvements possible? One, gain stabilization. Another, impedance adjustments. Another, noise reduction. Another, distortion reduction. Like that, several benefits are possible with feedback technique. However, one disadvantage is also there with the application of feedback. That is gain reduction. If it is 100 before application of feedback, the gain now is no more 100. It is less than 100. It may be 80 or it may be 75 after feedback is applied. Gain without feedback is indicated by A. Gain with feedback is indicated by AF. The relation between AF and A, it is given by this formula. AF is A by 1 plus beta A. 1 plus beta A is more than 1. Therefore, AF is always less than A. So, gain reduction happens when feedback is applied. It is a disadvantage. However, this reduction is compensated more than compensated by gain stabilization, by noise reduction, distortion reduction, etc. Here is shown the relation between AF and A derivation. Now, certain terms associated with the feedback, they are defined and introduced here. Loop gain, another name is also there for this parameter, return ratio. The product minus beta A is called loop gain or return ratio. Minus because it is negative feedback, beta is feedback factor, A is gain, basic amplifier. Minus beta A is loop gain. Another name is return ratio. Another term, return difference. This is also known as a desensitivity. The difference between unity and loop gain. It is called return difference, usually indicated by capital D. Difference between unity and loop gain. Loop gain is minus beta A. So 1 minus beta A is 1 plus beta A. D is 1 plus beta A. Amount of feedback in decibels, it is 20 log mod AF by A. Of course, AF by A is 1 by 1 plus A beta. we have seen in a previous slide. The amount of feedback is indicated by N. It is in dB. dB means 20 log applied. So this is the definition for amount of feedback. Another term, sensitivity. It is defined as a fractional change in amplification with feedback. DAF by AF is fractional change in amplification with feedback, divided by fractional change in gain without feedback, dA by A. This ratio of ratios is called sensitivity of transfer gain. DAF by AF is one ratio, dA by A is another ratio of ratios. A little bit of manipulation of the relation AF is equal to A by 1 plus beta A. It gives us sensitivity as 1 over 1 plus beta A. As already mentioned, the gain, a transfer gain of the amplifier, it comes down with the application of negative feedback. Transfer gain with feedback is less than gain with out feedback. The relation is AF is A by 1 plus beta A. Notice transfer gain may be voltage gain, it may be current gain, it may be trans resistance, it may be trans conductance of the amplifier. Transfer gain is general term, can be any one of these 4 parameters. A definite reduction will result from the presence of the feedback if the additional gain required to compensate what is lost because of presence of inverse feedback can be obtained by a readjustment of the circuit parameters rather than by the addition of extra stage. What is said here is implementation of feedback, negative feedback reduces the gain. So there is a loss, gain loss. Now there are 2 possibilities to have the lost gain back into the circuit. One way is adding another amplifier which will be able to give the lost gain to the circuit. Addition of an extra stage, amplifier stage. This is one way by which the gain is brought back to its original value. Here it is being told that that way is not preferred. Another way is usually used. What is that way? The parameters of the amplifier, they are adjusted. Basic amplifier parameters are adjusted and its gain A is increased so that the required gain is available with feedback. This is second method, restoring gain back to its original value by adjusting the circuit parameters. Basic amplifier circuit parameter. That is the best way. It gives better results than going for addition of an extra stage of amplifier. We spent some time on discussing general characteristics of negative feedback. Transfer gain with the negative feedback. What happens to transfer gain with the negative feedback? Already we have seen gain gets reduced. From the expression for gain of feedback amplifier in terms of gain without feedback, the gain of amplifier with feedback is less than that without feedback, independent of type of mixing as well as sampling. We are going to see types of mixing, types of sampling are there. 2 types of mixing, 2 types of sampling. Independent of type of mixing or sampling, gain always comes down when you implement negative feedback. Another aspect of negative feedback is desensitivity of transfer amplification. As already mentioned, gain stabilization takes place. It's a benefit when we adopt negative feedback. What is gain stabilization? Consider a voltage amplifier. Usually, the voltage gain offered by this amplifier, it depends upon the circuit impedance properties in which this amplifier is introduced. In one circuit, it may be offering certain amount of gain. Same amplifier, when it is introduced in some other circuit, it offers different amount of amplification. It depends upon impedance matching at the input side, impedance matching at the output side. So gain offered by the amplifier varies from circuit to circuit. Another aspect, amplifiers are made with one or other active devices, transistors. Transistors are semiconductor devices. Their behavior changes with the temperature, ambient temperature, humidity. Their behavior also changes with aging. When change is there in their behavior, there exists a change in the gain offered by the amplifier too. It implies morning one gain, afternoon another gain, today one gain, tomorrow another gain, this month one gain, next month another gain, like that. Instability is there. It is a disadvantage, a serious disadvantage, a shortcoming. This shortcoming can be overcome. It can be eliminated. At least a major part can be removed with the help of negative feedback. It is said negative feedback improves the stability. If the feedback network contains only stable passive elements, a substantial improvement in stability can be achieved. Voltage series feedback stabilizes voltage gain. Voltage series means sampling is voltage, mixing is series. Current series feedback stabilizes transconductance. Output current is sampled and it is connected in series with the input signal source. It stabilizes transconductance. Current shunt feedback stabilizes current gain. Voltage shunt feedback stabilizes trans resistance. Here the point which we have to keep in mind is, if we want current gain to be stabilized, current shunt feedback has to be used. If we want voltage gain to be stabilized, we have to use voltage series feedback. Similarly, current series for transconductance, voltage shunt for trans resistance. The stability is an important benefit provided by negative feedback. Another benefit that can be had by implementing negative feedback is distortion. Frequency distortion comes down. If the feedback network does not contain any reactive elements, the overall gain is not a function of frequency. Under these circumstances, a substantial reduction in frequency and phase distortion is obtained. Distortion means deviation of the output waveform from the input waveform. Waveform contains information. Deviation in waveform means information loss. Distortion results in information loss. So this information loss comes down when negative feedback is applied. Different types of distortions are there. In earlier we talked about frequency distortion. Now it is nonlinear distortion. The harmonics generated due to nonlinearity in the amplifier gets divided by factor D if the feedback is employed. So this type of distortion also comes down. Another benefit is reduction of noise. The noise introduced in an amplifier is divided by the factor D if the feedback is employed. In particular, the hum introduced into the circuit by a purely filtered power supply can be decreased appreciably. So noise reduction, distortion reduction, gain stabilization, these are all the benefits. Bandwidth can also be improved. Let us see what happens with bandwidth. Bandwidth increases by a factor which is equal to the factor by which gain decreases. The midband amplification with feedback A0F is equal to midband amplification without feedback A0 divided by 1 plus beta A0. Here one aspect requires to be mentioned. Gain is an important aspect as far as amplifiers are concerned, but much more important aspect is gain bandwidth product. For a circuit, especially amplifiers, not only gain, bandwidth also requires to be high. When negative feedback is applied, gain reduction is there. We thought it is a negative result, negative aspect, but this negative aspect is compensated in the increase of bandwidth, so that gain bandwidth product is constant. The high 3 dB frequency with the feedback FHF equals to corresponding 3 dB frequency without feedback multiplied by same factor 1 plus beta A0. Low 3 dB frequency with feedback FLF equals to corresponding 3 dB frequency without feedback FL decreased by the same factor. For an audio or video amplifier, FH is greater than FL and hence bandwidth is FH minus FL equal to FH. Under these circumstances, one can observe that gain bandwidth product is the same with or without feedback. So as far as negative feedback implemented amplifiers are concerned, gain reduction is there, but that reduction is compensated by bandwidth improvement. In fact, gain bandwidth product remains the same for amplifier with feedback and for amplifier without feedback. These are the points which I want to share with you. Before closing, let us recollect the aspects that are touched upon in the present session. Negative feedback, positive feedback, various terms associated with the feedback, a definition of feedback, benefits of feedback, all those things are discussed in the present session. We meet again in another session.